Everybody, in the previous session, we have discussed about first we have discussed about what is stack and why it will be used and what are the operations in stack like push as well as pop, and also the display operation we have seen in the previous two sessions. So now we will see uh, different types of exception that may occur during this one, that is while doing the push operation as well as pop operation. So before we will see what are exceptions. So exceptions are nothing but these are the conditions which cannot be which cannot allow the particular operation to do. That means here if I go for pushing an operation, so basically when we go for pushing, what should be the condition? The condition should be in such a way that the stack should have some space to push those elements. So in that case, if there is no place to push the elements into the stack, that means it is full. And if I try to push elements into the stack in that case, that means the exception occurs, or it is the stack is reached in a condition where if I try to push further elements, then exception may occur. And the same way during deletion also. So while the stack is empty and if I try to pop an element, that means it will there again it will create an exception because there are no elements to this one, that is delete or pop from the stack. So these are the conditions. So whenever we go for doing a particular operation or any work, there should not be a condition where it will stop our operation to do. Okay, in simple words I am saying. So that means those conditions, what they will do, they will not allow me to do that particular operations. Okay, that type of operations are called as what here? That means situations are called exceptions. So the same thing we are going to discuss in this class now, and how to test the exception conditions in the stack. So in stack operations like push and pop, these exceptional conditions will occur where as I said, they will not allow those operations to occur. The first one is push operation and the second one is pop operations. These exceptions will not allow either the push operation and pop operation to occur. So let us see what are those two conditions that give the exception situation for push and pop. The first one is stack overflow. So we already see that whenever the stack is full and if I go for pushing an element into the stack, then stack overflow occurs. That is the thing. So that is the condition. So when this happens, it happens when we try to insert an element to the stack which is already full. Okay, so then how to test this whether the stack is full or not? So before pushing an element into a stack, so for that we will use a if statement, and here you can see here I have written if top is equals to maximum minus 1. So what this indicate, max is the size of the stack. So here we are to, as I discussed in the previous sessions, we will write max minus 1 because this stack is implemented by using an array. So here the array indexes always start with what? 0. So if my size is stack size is 5. That means I have to, if I start with 0, then the last index should be what, 4. So that is why maximum value, that is 5 and minus 1. So 5 minus 1 is what, 4. So if top is equals to 4, that means if top is pointing to the index 4 of the stack, that means stack is full. Okay, that is the meaning of this. That means there is no more space to push elements into the stack. That is what this condition condition indicates. So this is how we have to test what here, the whether the stack is full or not. Now, what action or what error will be displayed if the stack is full and if we try to push the element into the stack. So here the message will be displayed, that is error message will be displayed, that is stack overflow. So that means what, here you should not try to push any other further elements into the stack. That is the meaning of the stack overflow says. Okay, so this is with respect to what here, the stack. Okay, the stack in operation, that is push. Now the same kind of this one exception occurs in case of pop also. Okay, if I go to remove an element from the stack, and in that case sometimes there occurs this exception condition. So what is that exception condition with respect to pop operation in stack, that we will see. That is nothing but the second exception, that is stack overflow. So this occurs during what, here, pop operation. So what is that condition which leads to that exception? It happens when we try to remove an element from the empty stack. That means there is a stack but there are no elements in the stack. So in that situation, if I go to remove an element from the stack, that means it is not possible because there are no elements in the stack only. So this condition will lead to this exception, that is stack underflow or stack is empty. So how we can check this condition? That is a question here. So we can check this condition by using a, again, if statement. Okay, so how we will use that condition or check that condition? By writing if top is equals to minus 1. So we all know that the stack index will always start with 0. First position of the stack is 0, second position of the stack is 1, the third position of the stack is 2. That means it will start with a 0. But if there is no element, okay, if there is no element in the stack, then what happens? Then the top will point to what, here, minus 1. Okay, if I push one element into the stack, then top will point to what, 0. But right now the condition is what, there are no elements. That means the top cannot point to either 0, 1 or any other index in that sense. So that is why the top should point to what, here, minus 1. So that condition we have to check before popping an element from the stack. So what is that condition? If pop is equals to, if as the top is equals to minus 1, then it has to, we should stop popping an element from the stack. That is the statement here with respect to what, this one, that is pop. Now we'll check this with by taking some of the code here. We have already seen this, just to understand what is this exception is in separate, I am explaining this to you. So you can see here we have written the code for this stack underflow. So This is what during, as I told, it occurs during pop operation. So int, the name of the operation is what, pop, and if top is equals to what here, -1. Okay, if top is equals to -1, that means the stack is empty, so it has to print what here, stack overflow, and then it will return what, -1. But if it is not, then it will go for popping an element from the stack. So the same thing happens with respect to push also. Okay, so here during push what we will do, first we will check whether the stack is full. Okay, that means if top is equals to what here, maximum -1, then it will print stack is full. That means stack is full now, don't try to insert any more elements. That is the meaning of this. Otherwise it will increment the top. That means by making top is equals to top plus 1, that then it will allow you to push the element into the stack. So that is how it will be done. So now in the diagrammatic representation we will see that condition. So you can see here, here this is a stack, and these are the data elements that I am pushing into the stack. So this is first data element, second data element, third data element, and fourth data element. So the stack size is only what here, 4. But what I am trying to do here is, I am still trying to push an element here, but there is no space further in the stack. So what happens here, the stack overflow condition will occur. It will not allow me to push an element into the stack. The same way, with respect to pop also, you can go for popping an element from the stack. Okay, so but if there are no elements, then what happens, the top will be pointing toward here, -1, and in that condition if I go to pop an element from the stack, then it will give stack overflow, or it also means no element is there in the stack to remove. So the textual representation of the same will be represented here as I shown. So before pop, what we have to do then, before popping an element we have to always check the basic conditions. So the basic condition is what, whether the stack is empty, that we have to check. Then if it is empty, then we should not go for popping an element, and if there are elements, then only we have to go for popping an element. So if we check this condition, what happens is it prevents program crash or undefined behavior of the program. Otherwise what happens, the program will crash, because we are trying to pop an element where there are no elements in the stack only. So why it is important to check these conditions or exception? These are very important because of robust and error free code. So if I have to write an robust code as well as error free code, then I have to write these conditions. Either it may be the push or either it may be a pop. So that is how we make sure that these exceptions will be handled by writing this conditions for exception checking. So that's about this session now. So I will stop for now, and in the remaining sections we will go further with the remaining topics. Thank you.